Okay, now that we have some of the basics under our belt, we can actually start taking a look at some of the other things that we can do with matrices, and not the least of which of these is adding two matrices together, subtracting one matrix from another, and scalar multiplication of a matrix, which is different from matrix multiplication. We'll get to matrix multiplication in a little while, but in this section, we're just going to be talking about scalar multiplication. We'll get to that in the next video. But for now, I want to talk about adding two matrices together and subtracting two matrices, subtracting one matrix from another. All right, here I have two matrices. We might call this matrix A and matrix B. And if I want to indicate that I'm adding together two matrices, I might write A plus B. I could also write the matrices themselves with a sum, a plus sign between them. And matrix addition is really very straightforward. All we need to do is to add together the components in the same positions. So to add together these two matrices, I'm going to start by adding together the first row, first column, the entries in the first row and the first column of both matrices, 1 plus 0, and I get 1. Then I'll add together the second row, first column, entries from both matrices, and I get -4 plus 0, which is -4. Just carrying on with the same process for each entry, I get -4 plus -5 for my second row, first column. Sorry, first row, second column, and I get -9 for that. And lastly, let's see, I have a different color here, last color, I get 3 and -4. Add those together, you get -1. So the result of this matrix this matrix addition is that matrix A plus matrix B gives us a new matrix. We might call it C, we might call it something else. But matrix addition is really very, very straightforward. Matrix subtraction is equally straightforward. Here I'm going to do A minus B for this matrix A and this matrix B. So I have A minus B. And this is the same thing, component-wise or entry-wise, one position at a time. I'm going to subtract these entries. So for the first row, first column, I'm going to have -3 minus 4, and that's -7. For the first row, second column, I'm going to have 0 minus 1, which is -1. For the first row, third column, I'll have 1 minus 4, which is -3. And then I'll go down to the second row, and I've got second row, first column, 1 minus -4, that's 1 plus 4, so I've got 5. And I've run out of colors. I'll use my gray highlighter here. Not very interesting, but that's okay. Second row, second column, -3 minus 1, so I get -4. And for the last one, I have second row, third column. I have second row, third column in the first matrix minus second row, third column in the second matrix gives me 5 minus 5, which is 0. So this new matrix that we might call C, or I don't know, you might call it M, you might call it T, it is a new matrix. It's matrix that's based on the subtraction of matrix B from matrix A. So as you can see, this first new skill that we're learning with matrices is very straightforward, but there is something we have to watch out for. I'm going to set up a matrix addition problem now that can't be done. All right, this is the first matrix from my first example and the second matrix from my second example, and I want to add these two together. So let's just pretend that I hadn't told you this wasn't possible, and let's just see what happens. First row, first column, I get 1 plus 4, which is 5. Second row, first column, second row, First column, I get -4 plus -4 is -8. So far, so good. I have first row, second column. Can you see what the problem is yet? For -4 plus 1 is -3. Let's see, what color should I use next? Here we go. Second row, second column. 3 plus 1 is 4. No problem there. The issue now is that I have no third column here in matrix A to add to my third column in matrix B. So there is no way to get the entries that should go here and here in matrix A plus B or matrix C, right? There's no way to do this matrix addition. So while the performance of matrix addition and subtraction is very, very easy and very, very straightforward, it can only be done on two matrices that have the same dimensions. If the dimensions of the matrices are opposite, as it were, so if you have a, let's see, you have a 2 by 3 matrix here. Let me put those in 1, 2, 3, 4, 5, 6. Right, that's a 2 by 3 matrix. And let's say I want to add that to a 3 by 2 matrix. 6, 5, 4, 3, 2, 1. You can't do it because I have a first row, first column in both cases. I have a second row, first column in both cases, but I don't have a third row in my first matrix to add to my third row in my second matrix. So it doesn't matter how similar or how close you think these two matrices are. They must have exactly the same dimensions if you're going to stand any chance of either adding them or subtracting them.